In 2023, DKM released the 6th generation of new low-inertia injection technology at Chinaplas 2023. This injection technology solves the problem of reduced machine response speed left by electric pre-speed technology or the industry problem of low injection repeatability. DKM's 6th generation low-inertia technology combines positioning and low gravity potential as a major feature. It also separates injection and moulding process, providing a new technical idea for the entire injection industry. In 2024, DKM optimized the injection unit on the basis of the double-cylinder technology and successfully launched a single-cylinder low-inertia injection moulding machine. The independent hollow piston rod and spline transmission technology completely solved the problem of oil leakage. The standard low-inertia technology allowed this series of injection moulding machines to achieve faster response speed and injection accuracy. On January 10, 2023, it was certified by the China Plastic Machinery Product Quality Inspection and Testing Center that the standard energy consumption of the DKM 250 low-inertia series injection molding machine is 0.35 kWh/kg, which is less than the Chinese first-level energy consumption standard of 0.4 kWh/kg, in line with China's first-level energy consumption level requirements. The rated clamping force is 2,500 knots, and the energy consumption is 0.35 kWh/kg, less than 0.55 kWh/kg, which meets the technical requirements of China's energy-saving products. DKM has launched 2 other original new technologies based on the successful development of dual-cylinder and single-cylinder low-inertia technologies. For double-stage injection, the current industry basically adopts the separation of plasticizing stage and filling stage. The screw realizes plasticization, the plunger realizes filling, injection plus pressure holding, and a rotary valve is added in the middle as an action switch. If used in the PET bottle preform industry, since the material from the front end of the injection piston comes out first and last, it will cause material retention, resulting in an increase in the AA value. At the same time, the rotary valve is in contact with the air, which greatly increases the risk of glue leakage. After research, we will find that while the screw is plasticizing, a certain pressure holding action is added. According to the DKM design, a 1D injection stroke is reserved as the holding pressure. Injection can appropriately reduce the piston diameter according to the actual product and mold. At the same time, in order to completely solve the problem of first in, last out, and discharge the material from the front end of the injection piston every time, we study the use of a machine hinge structure and effectively utilize the endpoint fixation and self-locking functions of the machine hinge movement, which can effectively prevent the material from reversing during pressure maintenance after completing the injection action. Flow phenomenon, and finally realize the separation of injection and pressure holding. MX Clean high-precision injection molding technology in the mold clamping mechanism of small and medium-sized machines. Whether it is a hydraulic press or an electric motor, a machine hinge mechanism is used. Due to the stable motion curve of this mechanism, through the amplification of the machine hinge mechanism, the thrust of the oil cylinder or screw rod is effectively amplified. It can reach dozens or even hundreds of tons of mold clamping force, thus becoming a classic mold clamping mechanism. If this mechanism is purchased for use in medical, precision electronics, optics, and other industries with high cleanliness requirements, clean molding will not be achieved because the machine hinges require continuous lubrication. To address this problem, the industry also uses solutions such as hydraulic direct locking. If a large hydraulic cylinder is directly used for direct locking, it will increase the energy consumption of hydraulic oil filling. In response to this requirement, the industry also uses a 4-tie rod straight pull solution. Since the mold shifting and clamping are performed inside the tie rod, this structure is complex and difficult to process. How to develop it from the first principles of physics to break through the traditional classic structure. After research, we will find that by shifting the mold and mold clamping are separated, and the screw mechanism is used to move the mold to achieve fast and precise movement. The mold closing adopts a cylinder structure on the tie rod, in order to effectively avoid a large amount of hydraulic oil filling and discharging. We adopt an equal area cylinder structure and design a fast speed in the center of the piston. The slide valve is used to charge and discharge hydraulic oil on both sides, thereby achieving precise and clean injection molding.